All right, we are on assignment 5, question 5. Was that what you asked for, Andrew?
Yeah.
Okay, so assignment 5, question 5. And have that in front of you. I'm going to write it down. They want the equation of the tangent line to the function y equals x squared plus x minus 2 over 2x. Is that the right one?
Yes.
Okay, at x equals 1. So is your question about how to find the equation of the tangent line, or is it the derivative?
Well, I got the y of 1. I was just trying to find the y of 1 plus h.
Oh, my friend, don't be doing the limit definition. You should be using your shortcuts at this point.
Oh. Okay.
So you want to rewrite it for sure, or you could use the quotient rule, but I would say rewrite this one. So does that answer your question? You think you can do that, or do you want more help on it?
I think I could do it now.
Okay. We'll leave that now, unless anybody else. Does anybody else want to see more of this one? Hi, Charlie.
Oh, hi there.
Okay.
I think I'm good on that one.
Okay, then I think Collie, you're up. Everybody needs to pick a problem and have a backup in case someone picks the same one. We're just going to do question and answer stuff and roll through as many as we can.
I had a question on number 10 on assignment 6.
Assignment 6, problem 10. Okay. Something specific about that one?
Not really.
Just the what the heck?
Yes.
Okay, so let me get it down. So at what point on the graph of y equals 1/2 x squared is the tangent line parallel to the line 2x minus 4y equals 3? Okay, so in geometry, we just learned about parallel lines and how slope is related to parallel lines. So here's some parallel lines. What's true of the slopes of these?
They're equal.
Okay. Okay, so let's think this out. We want to have a tangent line on this parabola that's parallel to this line right here. Do we have a way to find the slope of the parabola? Anyone? Okay, let's go on to this. How about the line? Is there a way to find the slope of the line from the equation?
Simplify it.
If by simplify you mean rearrange it so it looks like a line equation, more like y equals mx plus b form. Oops. Is that what we mean?
Yeah.
Okay, yeah, that would help us find the slope of it. So we solve for y to do that. So if y is alone, we've subtracted the 2x over to join that positive 3. And then as a next step, we're going to divide by the negative 4. We'll divide this. That means everything's getting divided by negative 4 over here. So what's the coefficient right there on the x?
-2. Negative 1/2.
Would it be
No,
negative?
1/2.
Positive 1/2.
Positive.
Positive 1/2 right there. And then for the 3 divided by that negative 4, call that negative 3/4. Okay, so the slope of that line is 1/2. So where on this parabola, and I'm graphing it only because I know quickly what that is. I really don't need to, but that's like a parabola like this. Where on this parabola is our slope going to match that 1/2? Because again, the slopes need to be equal. So I need a slope on the parabola that equals 1/2.
1/2.
Somewhere over here. Here's tangent lines. going to be 1/2. This is the slope, but we need to find the x value. So we're like, where on here? Where on the x do I find a tangent line sloping at 1/2? Okay, so the key concept is, again, how do you find the slope of that function, that equation?
Would you multiply it? Like 1/2 x times 1/2 x?
No. Come on, you guys. The slope of a tangent line is equal to the, you're in calculus.
Derivative?
The derivative. Exactly. The derivative. The slope of the tangent line is the derivative. So do we have a way to get the derivative of this?
Yes.
I think we do. And we don't have to do any limits to do it, do we?
No.
What's the derivative? Colleague, what's the derivative of 1/2 x squared?
Maybe x.
Maybe x. Is she right, Haley?
Yeah. I agree.
Agree. Bring down the 1/2. Drop it by 1. Okay, y equals x is a formula for the derivative anywhere on the curve that you want. What do we want our slope to equal?
1/2.
Ooh, that was stereo. Good job. So if our derivative is x, essentially, equal to 1/2, I'm setting the derivative equal to the slope of that separate line. There's not a lot of interest there to solve that, but that would be your answer. How's that? What do you think?
How do we find the y coordinate? Because it asks for the x and the y.
Awesome, really? Okay.
Yeah.
Okay. So we know the answer is 1/2 for x, and we'll say it's right there. How do we find the y coordinate if we know the x coordinate?
You plug it in.
Which function are we plugging into? Because now you guys are going to be working, this might be the first time where you're really working with two functions in the same problem. So there's an option to plug it into here or into here. Those are both functions. Which one do we plug it in to get the y coordinate?
So 1/2 x squared.
That one. That gives the y coordinate. This gives the slope. Okay?
Yep.
All right. We ready for the next one? Who was next? I think, Haley, you were next. I'm just going in order of who entered first.
Who? Me?
Haley, yeah.
Oh, okay. I had a question on
While she's looking, everybody, Charlie and Eddie, you're going to be next. We'll have a question ready, okay?
you guys hear me?
assignment 5, number 10.
Assignment 5, number 10. Oh, it's a normal line one. That one?
Yeah.
Okay, was there something specific about it or general question?
I didn't even know how to start it.
All right, the line normal to the graph of f at the point 1, 2 passes through the point -1, 1. Which of the following gives the value of derivative at 1? Holy cow, that is a lot. Okay, let's see, I'm going to diagram what we got. So 1, 1, 2. And okay, so what you want to do is draw just some random graph of a function that passes through that 1, 2 point. It's kind of random. And do you remember what normal means for a normal line?
It's like the exact opposite of the tangent line. I know, something like that.
Yeah, something like that. So if this is the tangent line, then the normal line is going to come in direct opposition, at making what angle with it?
90 degrees.
Right. There's going to be a right angle right there. So going back to the problem, that line that's normal to the curve or hits the curve at a 90-degree angle passes through another point at -1, 1. So -1, 1. Oh, that's up here. Okay, I'm going to have to revise my picture because that line does not pass through that point. So let me try again. This time I'm going to actually build it. Now that I know, we're going to build it a little bit backward. So the line that we are looking for goes through 1, 2, and goes through -1, 1. So here's the normal line. And then I'll draw a random curve that goes through that normal line at a right angle. So do you see how I got that right angle right there?
Yeah.
Then I have this random curve. So which of the following, multiple choice, gives the value of the derivative of f at 1? So we actually want the slope of the tangent line right there.
Right.
Now, Haley, you said that the normal line has something to do with the tangent line, that right angle.
Yeah.
You guys remember? We did this in geometry again today. Do you remember the relationship between the slopes of lines that are perpendicular? So let's say I know the slope of that line is, let's make it a fraction, like 5 halves. But it's dropping, so let's say -5 halves. What can I do to get the slope of the line that makes a right angle with that line?
Flip it and change the sign.
Excellent. So flip it means 2/5. Change the sign means not negative but positive. Make sense?
Yep.
Yes.
Okay, so we aren't going to be able to find the slope of the tangent line because we don't have a function to take the derivative. But we have a defined line here. Can we get the slope of this line?
Yes.
Yeah.
Okay, so what would you guys say the slope of that line is? And I'm thinking rise over run. That's what I'm thinking. What's our climb?
1/2.
1 unit up?
1/2.
2 over. Okay, so the slope of that is 1/2. Now, what does the derivative at 1 mean? In words, what does that mean? What does that have to do with the tangent line? I'm just going to start writing it out. First person who knows what I'm writing, just shout it out. No one. Oh my gosh. Can anyone finish it? I'm almost done.
+1.
Thank you.
Did I get it like a brownie point or something?
I think you do. I think you do. Holly +1. Okay. Okay. So what are you going to do to get the slope of that line? How can you use that to get the slope of that?
Flip it and change the sign.
Ooh, another bonus point. Brownie point.
I'm just racking it up.
You are. You are. Awesome. Okay. Eddie, are you with us?
Do you hear me?
I do hear you.
Oh,
For the first time, though, have you been talking?
oh, sorry. I wasn't sure if it was working.
Oh, yeah. Charlie, check in. Do we hear Charlie?
Yes.
Yeah, everybody. I can hear everyone. Do you have a question, Eddie?
Wait, hold on.
No, we cannot wait.
You needed to be prepared. By the way, Peter earlier came in and had a request because he wasn't going to be coming. He had a request if anybody had a question on assignment 6, question 6 or 7 or both.
I have a question on both as well.
Okay. Just FYI.
I have a question on a lot of them.
Okay.
I feel that.
Andrew's like, come on, Eddie, let's go. Charlie, tell me you're ready with your question.
I'm working on it.
Okay. All right, Eddie.
Assignment number 14. Oh, wait, no. Assignment number 6.
Okay.
Number 14.
Assignment 6, number 14.
Number 4.
Wow, that looks so fun.
I don't like the fact that there's a lot of variables.
I know, me too. I like it. Okay, we're going to do this derivative. This is a rule, a derivative rule. Okay, u and v, remember we talked about that in class. Those are just functions of x. So we're not going to be writing the big function. We're just saying function of x times a function x divided by a function of x. This was from product and quotient rule, wasn't it?
Yes.
That's what you get to do. So you have to take the derivative of this. Overall, this is a quotient. Ho-de hi minus hi-de ho over ho-ho.
Oof.
Okay, but when we get to the d high part where we're taking the derivative of the top, what's the top itself?
UV.
Wait, can you there?
Yeah, we're multiplying two functions together. So that makes that a product.
Mm-hmm.
So when we do this derivative, the whole derivative is a quotient rule, but inside the quotient rule, there's a product involved. So we have to do product rule too.
You have like a
Oh, yeah.
second derivative.
Not a second derivative, but two rules involved in the same problem.
Okay.
Okay, so here's what I like to do when I'm doing quotient rule. I like to make a template for it. Before I do any of the math, I just kind of get the format. It's going to be ho, d high, so something here times something here, minus hi, d ho, all over ho ho, which means squared. And when I do that, then it kind of keeps me on track of where I am in the process.
Mm-hmm.
Okay, so we're going to fill in the blanks now. So ho means just write down the bottom. So the bottom here is just w. That's that. The derivative of the top is ho d high. So the derivative of the top. When we do this, we have to do product rule for that. And the product rule is going to fill this in. So let's shift gears. What's the product rule? First times derivative of second. What's after that?
Second times derivative of first.
You got it. And we're going to add those together. So first is u. Derivative of second is v. So that'll be v prime. Then plus, let's switch it around. Now v times the derivative of u prime, right. All right. So when we step back and look what we got, we've got ho d high minus hi d ho all over ho ho. And when you look at your answer choices, do you see how that's starting to be built?
Yes.
Yeah.
If it's okay, I want to leave it there so you guys can finish that problem. Eddie, do you think you can finish that?
I'm not sure.
Feel that?
Your question, so we're going to leave it up to you. If you want to keep going, let me know.
Yeah, can we keep going?
Okay. Okay, so Hody high minus high. Eddie, let me hear you tell me the high.
Um,
Ollie, could you quiet down with the food? Eddie, what's the high? Do you know?
no.
All right. When we're doing high and ho, we're talking about the top of the fraction and the bottom of the fraction. So looking here, the top of the fraction is the high and the bottom is the ho. That sounds weird. Does that help?
Kinda, yeah.
Okay, so what do you think? What would we put here?
So, Heidi Ho, what? Wait.
Let me change my color. Okay, we're doing the product or the quotient rule, right? Do you know what I'm talking about? I'm just saying all this stuff. Heidi Ho. We wrote this down in class. Minus. Wait. I'm saying it backwards. What's the first part?
Hody high.
Hody high. So Hody high is what we did right there. We wrote down the bottom. Oh, can't see it, sorry. We wrote down the bottom. So ho and then d high means we took the derivative of the top.
Oh, okay.
And then here we're going to write down minus high and d ho. So we've got the top multiplied by the derivative of the bottom.
So it would be U and V.
UV for high?
Yeah.
And then what for d ho?
Then for D Ho, W prime or
Yeah.
yeah.
Now what's it all over? What goes in here? Leslie does not want them or like them, but I'm going to force feed her one. Ho. That's why we're squaring it, because we're going to multiply the bottom twice. So we just put in
W.
the W. Yeah, so it's all over W squared. So I'm going to leave it for you to finish that. It's just a little bit of algebra, and then you'll have it done.
Okay, thank you.
Okay. Okay, Charlie.
I think Peter had some pretty good questions.
He'll be so happy.
Question 7.
Okay. I'm going to put this out for question 7. These are actually, once you guys know what they're asking, they're actually kind of fun. So I think you'll like them. So U and V are these differentiable functions of x. Differential functions of x equals 3. That's a typo. That should just say of x. Okay, and we've got 10 minutes left, so this is probably going to be our last one. Oh, I just hit upgrade. Just kidding. You guys, where are you? Okay, I'm back. All right, so anyway, that's a typo, so let's just cross that out. Differentiable functions of x, just like what we just talked about. Those are two functions. The function value at 3 for u is 4, and the derivative of u with respect to x at 3 is -3. And then over here, they're talking about the v function at 3, it's equal to 2, but the derivative at 3 is equal to 3. So we're going to find these values at x equals 3. How do we take the derivative of a quotient like that? We just did it, right? So the derivative of this quotient is going to be the bottom, Hody high, so bottom derivative of top, minus top, derivative of bottom. Nope, I did that wrong. U v prime all over v squared. Got it?
Okay, that makes sense.
Okay, but that's the derivative for the function. We want to specifically give a value for at 3, what's the derivative? So we need to substitute numbers in for this. One at a time. What's the value of the v function at 3?
2.
Yep, right here, see? The value of the v function at 3 equals 2. So that is going to be 2. Multiply that by the derivative of the u function at 3. Anybody see that given?
-3.
Right here. The derivative of the u function at 3 is -3. So that fills that in. And you just keep going. So the next part is, what is the value of u at 3?
Four.
Right here?
Mm-hmm.
The u function at 3 is 4. Charlie, what are you thinking so far?
I don't know what I'm thinking.
Are you confused? What would Peter be thinking right now? Is he going to be confused?
Peter's confused.
Peter's confused. Okay. Okay. I think that maybe the notation of number 7 is a little bit trickier because this is pretty messy looking. If it's okay with you, I want to jump back to number 6. Try to get some unconfused people, okay? And we will do part D right here. All right, so these are two functions, g of x and h of x are being in a quotient. So if I'm doing the derivative, oh, you can't see that yellow very good. If I'm doing the derivative of the f function, I'm going to apply quotient rule to this. So I'm going to take the HODI high is going to be h of x times derivative of g of x. Is Peter confused so far?
No.
Okay. And then I'm going to subtract. What will Peter say?
G of x.
Times
H prime of x.
h prime of x. Peter's going to be so mad we're talking about him like this. The whole thing is going to be over h of x squared. Okay, questions on that step?
Nope.
Now we have to find, right here's the question, find the derivative of f at 2. So we have the derivative of f for every x, but we need the derivative of f at 2. So all of these x's need to be evaluated for x equals 2. So it's going to be h at 2 times g prime at 2 minus g at 2 times h prime at 2. Do you guys see what I'm doing?
Yeah.
Bottom will have it squared. The given information at the top tells you what each of those parts are. So you're just going to make some substitutions to go further. Let me get another piece of paper. I'm out of space on that. Okay, so looking at the top, what is, one at a time, what's h at 2?
-1.
Yeah, that was stereo again. What's g prime at 2?
-2.
Right here. Minus, keep going. What's g at 2? Charlie,
3.
what's g at 2?
3.
3, okay. And Charlie, what's h prime at 2?
4.
Okay, so you guys, we just plug in these values that we've got all over what's h at 2?
-1.
Yeah, okay, and we squared that. And then you calculate what that number is. You calculate the number. So these are nice ways, these questions are really nice ways to see if you know your derivative rules without getting a bunch of messy algebra into it. Let's look at this one as another, just quick. What's the derivative of 2 times a function of x? This is to see if you know your constant multiple rule. If we have a constant in front of the function, the rule says keep the constant but take the derivative of the function. So I'm keeping the 2, but I'm going to multiply by g prime of x. And I do the derivative here. Let me put derivative of f here. And then I add, this is to see, do you know the sum rule? And that's take the derivative of that term and add the derivative of this term. So that's just going to be h prime of x. And then your next job, which is almost done, you're going to plug in the 2 because each question wants to have this answered. What's the derivative of f at 2? So plug in the values from the given for each of these derivatives you have. Any questions about that? Yes or no?
No.
Eddie?
No.
Haley?
No.
Okay. Charlie?
No.
Andrew?
No.
Okay.
I think Peter understands too.
Peter might as well. Now, this is not any different except notation. This is the same thing. Look at this mess right here. Jennifer would be like, what is Leibniz thinking? But that's how Leibniz would write it. And Newton would write that same thing as v prime at 3 equals 3, because x is 3 and the derivative is 3. That's how Newton would say it. So it's the same thing, just written in other notation. Okay. The only thing that's bugging me about what I wrote right here, and I'm not going to let this stand, is that I said this derivative equals this, and then I said it also equals this, and that's actually wrong. I need to write the derivative with respect to x of u over v evaluated at x equals 3, because I have plugged in the number to get these numbers. That's the proper way to write that. Similar to when up here I changed it from f prime at x to f prime at that specific value right there.
Okay.
All right. Okay, so they're going to cut us off in 1 minute and 24 seconds. Does anybody have any last desperate comments?
No.
Okay, I'm going to put this, like I said, I'm going to record it and I'll post it on Canvas. So if you want to look back at it for anything, you can. I really appreciate you guys coming to this. So I'm going to put some extra credit in. I probably won't do extra credit like week by week. It just makes the grade book huge. So I'll probably give a lump grade at the end of a grading period. I'll put the extra credit in. Does that sound okay?
Yeah.
Okay, awesome. Thank you guys for coming.
Thank you.
You're welcome.
Yeah.
I'll see you tomorrow.
Okay.
Yeah.
Bye.
Bye.
Bye.